This is the Wednesday, 30th of January, 2019. Cluster API provider implementers office hours for Europe. We've got one thing on the agenda from Pablo to talk about Cluster API provider for client. What would you like to talk about on that?
Okay. Well, I just sorted getting through the documentation and the specification. So, and also, seeing how likely is to implement the dynamic creation of nodes in Kind. Apparently, for what I've seen through the code so far, it will require some refactoring of the code, but the pieces are there. Mostly because Kind has done a very nice work on creating a framework for executing action on nodes. I mean, it's like a very structured way of creating that. It's not a bunch of code. It's something which is split in actions, and you can schedule action on nodes. It's very nice how Kind has structured the code. So I'm confident that that part will eventually be easy to implement. What I'm now trying to figure out is how to start. I mean, what will be the easiest or shortest path to creating a initial, I would say, it's got full code for a cluster provider. I mean, it's what should I do? There is any sample, any basic stuff? Because I see just this morning someone on the Slack channel that mentioned that he's implementing a bare metal provider for cluster API. And it was like saying, I'm just starting, I create a project and make like an initial commit. I will take a look at that because it was probably easier to start with something which is like very basic, just to track the common part. Well, I was wondering, did you have any template or because I suppose there is a lot of stuff which is common because it's basically all the types you need to use for the controller or stuff like that.
Sure. Well, I mean, it depends really. If you really want to use parts of the cluster API project, you could do that. But I mean, within EKS control project, we have cluster API implementation that has been worked on. And we didn't find it very useful to actually use the common parts because all of that was quite different from what we needed. So we have a cluster API of our own, at least for the time being. We're looking to later discuss which common parts don't match and how that works. But for the time being, we started with an implementation of our own pretty much from scratch. Right? So, but the thing is, we already had a CLI, and we wanted a CLI config file support, so be able to create clusters based on config file and update them based on config file, etc. So we wanted that, and we didn't want the controller to begin with. We just wanted to fit cluster API style config files into a CLI, into EKS control. And we found pretty much most of the cluster API repositories bits, like all the code that is in the cluster API repository, was hard to fit into this model because it kind of does completely different things. So for the time being, we are working with our own implementation. But obviously looking forward to a discussion of how an implementation with code sharing would look like in the future. Yeah. So
because I think even the types, because the types are not, I mean, so far I've seen that, for instance, all these API schema, all the Go types are not being exported like a Go package that I can install and reuse. It's like I need to copy that code in my project, right? Is that correct?
Yeah, that's a common way to do that. Yeah, exactly. And you kind of basically run a code generator, and you get some of that code, which you may find useful, but equal. There are chances that in some cases you may not find it as useful.
Yeah, so I think, so when the cluster API moved to the CRDs, it got rebased onto using Kube Builder. So I think most of the providers have moved to that. We're currently doing some stuff in AWS to add Bazel hooks to automate that copying process. So you don't actually have to do it directly, and you don't have to directly copy paste again. Some of that will be like an automated Bazel rule to take the common cluster object types from the cluster API repo, and then you add your customizations on top. So I'm still finishing that work. Yeah, I think probably the main difficulty you got right now is because cluster API is built around running as controllers, and you need a bootstrap process to do that, which right now is either Kind or Minikube. So there's a bit of a chicken and egg problem there. There is an intent to do like a one-shot process, which will behave a lot more like what's Weaveworks has been doing in EKS Cuttle, but that work hasn't really started yet. But probably we would be able to leverage the controller code, call directly into them, for example, from a command line, and do that.
So we kind of start the other way around in EKS control, right? We already had a CLI and a framework for doing a number of things within the CLI, and we just add a config file support, and then we can turn that CLI into a daemon, essentially. That's kind of the idea. But like you would be able to deploy, you would be able to use the CLI to deploy the first cluster, and then make that cluster a management cluster of your many other clusters, right? So you would be able to use a config file to create a management cluster, and then management cluster manage other clusters, and you'd be able to update management cluster using the CLI, or potentially even put those objects that manage the cluster itself, like self-referential types objects, into the cluster itself. So that's to be figured out. The idea essentially is to kind of deliver some useful tool to the users who would be able to use a config file and check that in, and being able to eventually update their clusters based on that config file, you know.
And this
So it was the Kind project. What sort of use case? Maybe you could talk a little bit more about how you'd like it to work in the particular context that you have in mind.
Well, the main point is that SUSE as part of the work in the CAS project, or actually the open source version, which is the Cubic project, which is a container as a service platform. We started using Kind for testing because it's really lightweight. It's perfect for continuous integration. It's quite fast. Just yesterday, this morning, I was just making tests, and I created and deleted cluster like one every 2 minutes or something like that. It's quite fast. So we said, oh, that makes sense. And also there is an additional interest for us that they use kubeadm for bootstrapping the cluster. Basically what they do is that they run that, and we also do that. So we also have interest in kubeadm. So it's like the architecture and the approach was really appealing. And then in the last couple of weeks, they have been like crazy adding stuff. They introduce the multi-node cluster, the one master node of multiple workers, but now they are also introduced multi-master, and they're moving very fast. So now they are like really capable of creating complex clusters, and for us this is important because it allows us to test our software in multiple cluster scenarios, not a simplistic one. That's the main initial interest. And I particularly interested also in the dynamic part because I work for SUSE in this cluster management technology. I mean, we are now evaluating how to implement that multi-cluster management by having a way to do it, and it seems that Kind could be a very interesting development environment for us, because I need to start like playing with the API and understand better the cluster management API. And that's what takes me to the dynamic part of creating dynamically clusters or nodes, stuff like that. So that's more or less the overall idea. I personally focus more on the cluster API, understanding better, understanding what it takes to implement it. And Kind comes from like a tool that happens to be that is aligned to the same architecture. They already have Kudam internally. So for us, it's like, looks like a good combination of using Kind for development and of our own cluster management. I don't see the chicken and egg in the sense that, as you said, you first create one cluster that can be a single node cluster, a single master, and then you bootstrap the other cluster from this. So you're probably not running, you're not managing the master cluster or the seed cluster using the controller, but you can use that controller for creating others. That's more or less the way we plan to work.
Sure. So it's just like, it's like, it is whether your target user is happy with the idea of creating a cluster for some temporary use or having some kind of parent cluster, right? So because for the case of EKS control, obviously there is that would be like a negative feature, right? People wouldn't be happy to have to, like, if you were to say, hey, before you can create a cluster in EKS, you need to run some little local cluster. That just doesn't make a lot of sense to many people. So yeah, and some people just want to be able to define a whole bunch of parameters in a config file and create clusters based on that. And multi-cluster management is kind of a secondary idea that for people is nice to have for people, but isn't necessarily essential. So if you're happy with, and if your users are happy with having some kind of central management control plane, which everything depends on, that's okay. Or if you can rely on the fact that they all run Linux and you can run Docker, that's totally fine too, right?
Yeah, well, your case is basically that, because our product, our system product CASP, it works like that. I mean, you basically bootstrap. Actually, you have an admin node that is not even the cluster, master cluster node. And from this node, you manage the rest of the stuff. And our customer can handle that easily because they understand that you need to have a reliable way of management. What we are working is in having high availability of all these components, because obviously your cluster cannot be more reliable than the control plane. So, but yes, I mean, for us, that's not the problem issue. It's how it works now, and our customers are perfectly comfortable with that. What is true is that now this admin node it's like a separate entity, which is not even a Kubernetes cluster itself. So one of the objectives is probably really use it as a Kubernetes cluster, so all components are actually operators running there. I mean, migrating a operator-based architecture because we think it's easier. We have started doing some development, like for instance, automatically upgrading or deploying the certificates if you want to use your own registry for downloading the images for Docker, and you need a certificate. We create an operator that automatically deploys or refreshes that, and it's that simple. I mean, once you get it, the idea is it makes sense, a lot of sense. So probably our future architecture will be a real Kubernetes cluster managing all the stuff in one or more cluster. More for us, it's more interesting in multi-cluster, because then you can justify having a dedicated management cluster, because you spread that cost among multiple clusters.
Sure.
And we are seeing that our customers are slowly moving to these multi-cluster setups for management, basically.
Yeah, that's understood. I just sort of wanted to give you one use case just to be clear what the kind of things I'm thinking about, and I think are important, maybe less important to your customers. Let's say I wanted to use Kind with Cluster API in Travis CI or something like this, right? And I have a couple of projects where I do that, but they don't necessarily have to connect to anything in common, right? There is no like central cluster for any of them. And I just use kind, and I would prefer to use a configuration file over arguments, right? So I wouldn't use a cluster API object to define the shape of the cluster that I want, and fire it up in Travis CI, turn it down. So that sort of thing, right? So I think legitimate use case, which may or may not be important, but that is something that becomes harder if you on some kind of a temporary cluster, or it's like it stops making sense if you create a temporary cluster in the first place to create another cluster which is actually in itself temporary as well.
No, it's the same. I mean, for testing what I mentioned before, all this we need a test. Be able to create multiple test environments easily. So that the idea of using kind is because we had found that we need a easy way for testing our cluster management stuff on cluster, but without having real cluster, because that's at this point we were using, for instance, creating cluster in OpenStack, but it's slow. The CI test lasts probably half an hour while you schedule stuff and you bring all the virtual machines. It's really heavy, and you don't want that for developers, and you cannot run that test in your local machine. So the idea of using kind is for developers, for us, for speed up of development of our cluster management, because you can easily create clusters on demand and test multiple configurations, and even testing what happened is over one cluster you, for instance, roll out and update. I actually started using kind for that because I was creating this controller for deploying the certificates. So I need to test what's happening. You have multiple. Know what happens if I remove a node from the cluster, how the controller manages all these events, and then I need a cluster. But it was more simple for me if I can run it in my laptop. I don't even need a server for that. I was running that with 4 nodes. It was like fast. So we realized that kind is really appealing as a test bed for more than simple tests. You can really come out to complex setups. And for us, this is important. I would say that it's probably one of the things that was slowing down the development was that the difficulty of making a test fast for developers. You need to wait half an hour for a test. That's not good.
Yeah, absolutely. Yeah, I know very well that what that implies. Yeah, no, absolutely. I just sort of wanted to make it clear to you, and that there is that one sort of fundamental question that you need to ask yourself. And if you are happy with a dependency on some kind of temporary cluster, or whether that's Minikube or something else, then that's fine, right? And then you should be able to use cluster API bits easily. The exact instructions I'm not too sure of, but like basically it's like Kube Builder plus a few bits. But Nadir, you said you've got some Bazel stuff brewing up. Is that something that could be tested already?
I'm trying to get it finished this week, basically. So there is a Git book. I can't find the URL. I haven't been able to for a while. So David Watson from Samsung wrote a implementation guide, basically how you would create a provider from scratch. I think there's been some issues publishing it, but there should be. I found
it as in a presentation. What I was not sure is it was updated or not, because the presentation was from last year. Like summer last year or something like that. So I found this URL.
I think it's later than that, but maybe ask me on Slack, and I'll try and find it. I've got a version that's published on my GitHub just because I was testing it.
Okay.
So that it shouldn't be too out of date. It is based on the AWS repo, and I think Azure, it might be another one to look at because they recently aligned with the AWS provider as well. So they've just done a lot of work too. And so their one is pretty close to the AWS one, and probably the vSphere one as well. I'm not sure how. I think, yeah. So we're using Bazel quite heavily, which is got its positives and negatives.
Okay.
But yeah, I think, yeah, let's sync on Slack and try and get Gitbook. I think you're definitely right. Like having the cluster API implementation with Kind would be great for people who are developing multi-cluster management. And I think one thing we haven't properly tested even is like, does cluster API work with multiple clusters in a single namespace? We think it does. We've never properly tested that. Like these are things we need to understand about the way cluster API behaves. So I think this potentially is quite a good idea.
Okay.
Yeah, I think it'd be interesting if one day Kind could replace Minikube and the AWS providers.
Kind does. You can use Kind right now.
Oh, so.
I like how it sounds. Sorry. Pavel here, hello.
Hi there.
Hey, how are you? Sorry, I'm not on video, I'm on the phone. Kinda exhausted, long days. So if you found this documentation on how to start from scratch, I have something like multi-master and I want to have multi-master now, but want to have a multi-cluster. And yeah, testing this would be something great because, you know, you said it once, it worked and you have it, right? So let's say you want to start developing and see how every change behaves. That's great. Thank you, because that's what I'm interested in lately. So if you found that DAC, so could you put it here, or maybe it's with some kind of, I don't know, password credentials on it? Easy. That will be the question.
I'll put an action item. I will find link and put in Slack, in cluster API, and also just email it around again to SIG cluster lifecycle if you're not already a member of that.
I think I am.
Yeah, so I'll send it to both those places. Yeah, I don't think I'll be able to find it now.
No worries. This is just something to think of.
Yeah. I found the book.
Okay.
I had that in the chat. Is that?
Yes, that's the one.
Okay. Yeah.
Thanks, guys.
Okay. What I was saying that as there have been some important changes, I understand in the last couple of months in the specification, I was unsure if this book is outdated or
it
or
might
not.
be a little, but it shouldn't be too much. So that we're currently burning down on a proper V1 Alpha 1 release of the cluster API. We've been in V1 Alpha 1 for ages, but hasn't really done anything. So the idea is to, I can't remember what the time scale is. It might be 8 weeks, but to actually nail down what V1 Alpha 1 looks like. There is a proposal to significantly change the API. We don't know if we'll do that for V1 Alpha 1 or the next release. So that will require big changes to the book. I think whatever changes there are right now should be relatively minor, and shouldn't be. The book should be good enough to get started, and certainly ask questions in Slack if there's issues. But yeah, we will definitely have to get that book up to date for when V1 Alpha 1 gets cut.
Sorry, I didn't get. When are you presenting this change? I haven't seen any pull requests, right? Has you put it?
I think it's in a Google Doc at the moment. So
it was mentioned yesterday in the cluster lifecycle call.
Yeah, I think it was. I should have a link to that one as well. Yeah, it was discussed last week as well, and I think it will be discussed today as well.
Okay, I will be in the meeting today.
Cool.
Yeah.
Basically, the idea is to so if you, I think a lot of the ones are similar, but if you look at the AWS one, for instance, you define a cluster, and then that goes out and builds things like VPCs and subnets and NAT gateways and Ethernet gateways. That's not suitable for a lot of people. Like, they have their own existing infrastructure and want to bring it. So what does it actually mean to have a cluster? So the idea is to maybe split out some of these objects. So we have a control plane object, and then that might be your choice of an EC2 kubeadm build or EKS control plane, and then separate the nodes completely from what a control plane is. And a cluster might just have the common information that defines how those nodes are linked into a cluster, and a separate infrastructure API that might deal with provider-specific infrastructure like VPCs, subnets, NAT gateways.
Okay, but that part is intended to be part of the specification, right?
Yeah, and that might go in for V1 Alpha 1, and that's quite a big change then.
Okay.
Yeah, that's interesting. That's I mean, I kind of welcome that change broadly, and I think there is still a lot more to do though, because I think at the moment the kind of shape of cluster API overall, as defined by pre-Alpha 1, is kind of hard to use really. I mean, there's some unnecessary verbosity there, and it just happened to be in a certain way. But I don't think it has to stay that way. There are probably more user-friendly things we can discuss, basically, anyway.
Yeah, I agree.
I had actually a few ideas, and I wanted to run them by a few people first. I don't know if you'd be up for having a chat about it.
Yeah, let's do that. So I think the people who are doing that proposal are Vince Pugnano from VMware and Robert Bailey from Google. I think are the two main people working on that. So yeah.
Yeah. So, but that doesn't change the inner structure of objects generally, right?
Sorry?
It doesn't change the inner structure of any of the objects. It just sort of changes the splits up subtypes and stuff.
It could do. I mean,
that would be a beautiful concept. Yeah, I mean, that is a beautiful concept.
We could make that change. I mean, I think if we're going to make such huge, gigantic changes, we might as well.
Okay.
Maybe I don't know. I think that's my personal take is, let's do that.
Yeah, I was just
it's kind of worms.
Because I was basically thinking whether it even makes sense to keep trying to implement, to keep trying to define like universal objects for all the providers that may become a union of all the providers, right? So I've been wondering whether we could have like a generic layer which basically represents a cluster, and then is just a pointer to another object, like a reference. It holds a reference to another object that actually is defined in the provider-specific way. So that so it's kind of like, I don't know. I mean, did I have any examples? Let me just look it up quickly. We do still have time at this call. We can sort of briefly touch on that if people like.
Yeah, I'm just.
Yeah.
But I mean, what you mentioned, for instance, at the node level, with the API already have this placeholder for provider-specific definition of the node characteristics. My understanding is that for the cluster, we should have something similar. It's like we have the control plane and some basic information that is needed for the control plane, like the IP range, whatever. And then have the ability to have like a more provider-specific specification of, for instance, a subnet or whatever, physical, I mean. But what do you think is too verbose about that?
Me?
No, Ilya was saying that he found the cluster API like trying to be a commonality of multiple providers, but my understanding is that it is not in its present form.
Yeah, as of now, it's not.
Sorry, I was muted. I was trying to speak. Anyway, so what I was just trying to clarify what I'm trying to say. I believe that currently what we're talking about as cluster API, as it's currently implemented by a few providers, it tries to be a union while not being really a union, right? So it's like there's the node object, for example, and then there is like provider spec within it, and each provider will have a different spec. But I haven't seen a provider where a thing where multiple providers will be combined. And it's kind of like, it tries to be a union, but it isn't really, right? That's what I'm trying to say. So what I was thinking is whether we could, whether it'd be a reasonable idea, and I'm asking you now, as we started discussing this anyway, whether you'd find it reasonable to have something like what I'm showing on the screen right now, where we have like a high-level definition of a cluster provider that sort of basically registers with cluster API controller, and it says these are the objects that I have, which represent things that mean something to me, right? It just sort of registers itself as a cluster API provider, and then that is the sort of a handshakey part. But the actual definition would be something like this. So there's a cluster, and it has a name, a region, and some other metadata, and then it has a spec, and it refers to some node groups, and then there are node group definitions, right? And this is like the provider-specific object, right? So this is something provider knows about and provider cares about, and something that a user of a particular provider would care about. But we do obviously need a common thing that would be understood by high-level tools, and that thing I was thinking could look more like this. So there is a cluster object, there is some metadata, and there are owner references which point at the provider-specific thing, right? Which is a particular bare metal cluster, which happen to have a name cluster 2, and there is potentially a shared thing which indicates the status, whether the cluster is ready, and what's its API endpoint, and the CA certificate potentially. So that kind of thing. So essentially there is the generic outer thing that only holds a reference instead of holding a union.
Okay,
So,
okay, okay, now I get it. Makes sense, I mean.
So at the moment we kind of have like this sort of gigantic object that tries to be a union, but there isn't a way to actually create a union, right?
Okay,
singleton, isn't that?
I understand. No, makes sense. For me, make a lot of sense. Unfortunately, I don't have the experience of trying to make this real, so I cannot give you a real feedback of this makes sense from the perspective of using it. But conceptually, I agree that it's probably a cleaner separation of the common and the specific part, just having different. It's that way you have the freedom of, as a provider, even upgrading your objects individually from this part.
Yeah, and you because I mean I think that there are very few things that are very much in common between providers, right? That really matter to the end user after all. There are provider-specific things that really matter in the context of that provider, but there are so many things that really don't matter. And the only thing that matters is Kubernetes. It perhaps has a version, and you know, it has an endpoint you can connect to, basically. So this feels like enough to describe an actual cluster to me. And then there is the more detailed provider-specific description, which is in a separate object, which makes it simpler for the end users and the provider implementers, I think. So here are some more specific examples of those objects. And we can see how quite different they are. So for the EKS cluster, we have this sort of very simple object that the user can specify, and they don't need to specify too many fields. And they may not care about certain fields that they may care about in the case of bare metal. And so here is a bare metal example that we can contrast it with, and we clearly care a lot more about our networking setup and where the DNS lives and other things. And then there are various other examples.
Yeah, DNS will be a puzzle here.
Sorry?
Different DNSs and from providers would be a puzzle here, but I think it's. Yeah,
I mean, this is just an example. This is very hypothetical.
I know, but still, it seems like to be a natural step forward. Anyways.
I didn't exactly understand what you meant, but this is just this is not trying to suggest a provider implementation, but it's just something that I've made up as, you know, spend 10 minutes thinking about the bare metal provider and what I would care about, in contrast to what I would care about in the EKS cluster, right? So, so the idea is broadly that, you know, you have the provider-specific objects that are entirely separate from the cluster API objects, and what cluster API defines is, you know, the common sort of cluster and node set type objects, which which rely on referencing for the actual implementation. Right. So you would be able to come up to a cluster and type. So the idea is that essentially you'd be able to come up to a cluster and either make some API calls or type kubectl commands where you'd be able to say, okay, well, this is my management cluster. Let me ask how many clusters it manages. So you'd be able to ask that question. Or you'd be able to ask a question of how many nodes there are in each cluster. How do I connect to each individual cluster, right? And you'd be able to ask those questions in a common way, in a standard way. But anything that is specific to the provider would be dealt with on provider-by-provider basis. So basically, that's the idea. So you'd be able to say, you know, kubectl get clusters and kubectl get node sets or kubectl get nodes or whatever. I mean, or whatever we decide to call those machines or anything. So that's roughly the idea. And I wanted to run it by a few more people before I kind of present it to the wider audience.
I think if you can use Terraform or something like this to, you know, multi-cloud infrastructure for now, then yeah, creating the object of you know, more abstract interface sensors or something like this is natural step here. And all the details, I think it will just come, you know, people will create GitHubs and yeah, and anyone else will be creating PRs for those. And yeah, I think it's a beautiful idea that, yeah, a natural step forward, something like this, right? Because this is just a draft, if I understood that correctly.
Yeah, this is.
I really like that draft.
This is a draft of how Cluster API could look like if we were to sort of stop trying to make it a union of all the providers, which it never is going to become, and you know, define a very lean, very lean object. Very lean set of objects that would be in common, and the rest would be, you know, implemented on through all the references like this in terms of the outer API, and then there should be some kind of inner API because we have to like communicate back the endpoint and certificate data and stuff like that, which I think is quite important.
Yeah. Separating the APIs is something else. You have this architecture where you have, I don't know, API, and you have the other API on storage, for example, for storage services. So this is something similar, and I think that's, yeah, that makes sense.
And then at the sort of like when, so what the idea architecturally is that, you know, you create this cluster and you install the cluster API controller into a cluster, and that becomes your management cluster, but it doesn't have any providers yet. And a provider can come along and say, hey, I'm a cluster API provider, and these are the features that I implement. And these examples over here would describe a potential EKS provider and a potential bare metal provider, right? And then it would say, well, these are the kinds of objects that I know how to manage, and I'll take those from you, and then, you know, there is some other bit of the protocol that I haven't specified where we would be sending back the data about what is it, the this status field for the cluster. I lost it here. So if we wanted to tell it to tell cluster API about our health and endpoints, there would be another API for the provider to communicate to the cluster API controller. So this is roughly the idea. So it sounds like you folks think that this is potentially plausible. Nadir, did you have any thoughts? I think Nadir is offline.
I know. I found it resume. I mean, I think that you have a good point. I think that is definitely better than have it embedded provider-specific stuff. Even for programming, the provider itself is easier. It can handle its own stuff separately. You can even upgrade the providers implement the specification without touching the cluster, which is separated. So I see that a lot of interesting point here. What I don't know, because my understanding is that the idea was like closing these specs, major or breaking changes anytime soon. So probably I shouldn't wait too much before at least introducing the idea, even if you don't have a final draft.
Yeah.
People is aware that something is coming.
Yeah, it sounds like there's some movement with respect to the overall shape of the APIs. So maybe it's reasonable to suggest this without further ado.
Yeah, I would definitely like. I think it would be better to look at I think you should definitely look at the existing proposals. Which
so this is something I wrote a couple of weeks ago that I wasn't aware of anything happening just yet, so I was sitting on it for a while thinking when time comes.
It has been in the meetings for a while. So there's that. There has also been talk of the generic provider. So I think this is probably related to the bare metal thing that I think probably someone's mentioned. So the generic provider is a lot of the providers are actually implementing the same things over and over again. Just got another delivery.
Yeah. It's always about integration, isn't it?
Be back in a sec.
Okay.
It's always about integration, isn't it? Right?
Yeah.
So the generic provider is going to take those sort of common bootstrapping issues and initially will be in a separate repository. And the idea is to then experiment with webhooks for provider-specific implementations to plug into. So it's actually kind of similar to what...
except that it sounds like...
It's been written up yet. So this is another way that's been sort of described to attack the same problem. And
yeah, I think what you're describing is the bottom end of it, and I'm talking about the kind of the overall shape of the actual API, kind of objects that user define and how do we deal with it.
What you mentioned is interesting because this already because the documentation of the architecture. I can recall where I think it's the book that mentioned that the idea that you have the provider, that you have the actuator, which is the one, and actually the actuator is basically a simple generic CRUD API: create, update, delete, and basically, in my understanding, that then you can separate this generic part. But interestingly, according to your proposal, it's like what they will be changing is probably more this provider-specific part, because the other is generic. Let's say, hey, I need you to create this specific cluster with this bare metal cluster. So you hook to the actuator. But I think that this idea is already somewhere. I don't know in the API itself, but at least the idea has been around. So for me, that's probably make a lot of sense, because this interface needs to be, personally, this interface is passing this opaque object, generic stuff, and say, hey, I have something that is intended to you, or this is something that is like embedded. So in your proposal, there will be actually separated. I think it's a lot cleaner to do that.
Yeah, well, okay. let me try to discuss internally and see if I can share the document as it is. Yeah.
Okay.
Yeah, I would love a link to the document in the thing. I mean, I probably will just steal it from the recording anyway. So, so it's going to be in there one way or another.
Yeah, let me just have a quick look at it, and I'll probably send it to you in a bit, Nadia.
Sure.
Okay.
Okay. Cool. Oh, we haven't finished yet. There's 10 minutes to go. I mean, I'm going to stop sharing and see what needs changing in this document, if there's any internal information or anything like that.
If I've not recorded anyone's thoughts accurately, please feel free to modify. we don't have anything else on the agenda. So if there's is there anything else anyone would like to talk about? Or otherwise, we can call this meeting to close and you can have 9 minutes back. Oh, all right then. Probably see most of you later for the Cluster API call. See you later. Bye.
Bye.
Okay. I'm looking at the okay.